Okay, number 9. When you were working number 9 yesterday, you should have got y equals negative, parenthesis, x plus 4, close parenthesis, cubed, times x minus 4. Okay, now let's talk about y. The reason I put a negative is because it goes down. It not only goes down on the right, it goes down on the left. Okay, but really, to determine whether to put that negative or not out there, you look at the right side. If the right side's going down, you put a negative. If the right side's going up, you put a positive. Yes, Rob? Okay, then the reason I cubed this is because at negative 4, it flattened out. Over here, it just crossed straight through at positive 4, so that counts as an x minus 4. Any other questions about that one? What's the degree? 4. Okay, and that's an even graph, and that makes sense that it's degree 4 because 4 is an even number. How did we know it's even? They're going the same direction. Okay, number 10. Y equals negative, because from left to right, you're going down. Okay, over here at negative 1, 2, 3, 4, we have a bounce, so you square. And then over here at positive 4, which I would represent with an x minus 4, it just crosses through. What is its degree? 3. And then an odd number because your graph's going opposite ways, so it has to be odd. Your degree is always higher than one number than your turns, one higher number than your turns. Like, see how this one turned twice and your degree was cubed? Now let's look at number 11 together, because this is a different way. You haven't been asked this way before. Sketch a graph with the following zeros. 2, 2, negative 4, 0, and a coefficient of negative 1. So what is the degree of this polynomial? 4, because there's 4 zeros. Does it have any multiplicity? Yeah, there's 2 2's. So that means there's a multiplicity of 2 at 2. So when we plot our 0 at 2, right below it I'm going to put B for bounce. That way when I'm sketching it, I know to bounce right there. Okay, so what else can we know about this graph besides the fact that it bounces at 2, crosses through a 0, and crosses through a negative 4? The coefficient's a negative 1. So that means our graph is going to go down on the right. Is it going to go down on the left or up on the right? It's going down on the right. So what's it going to do on the left, up or down? How could you determine that? Look, the degree's even. Because it's degree 4, there's 4 zeros. Remember, the bounce counts as 2 itself. So that means it's even, so that means they're going the same direction. So since it's negative, they're both going down. We're just not quite sure what goes on between them. I mean, we know now. We know it crosses through at negative 4 and 0, and it bounces at 2. So over here, we know it's going down on both sides. So we know we come up, cross through. Do we really know how high we go up before turning to come back down? No. So we come back down, and then we go back up and bounce off, and then go back down forever. How many turns do you see? 3. And doesn't that make sense? Since our degree is 4, our degree is always 1 higher than the number of turns. Okay, now the only other thing I want you to do for this question is to write the equation in factor form. So y equals, what would I put first? A negative sign, because it's negative. Then what factor would I list first? The 1 for 2, so how would that be represented? And what do I do to that one? Square it, because it's a bounce. Hold on, I know what you're going to ask. We'll get to it. Okay, then the negative 4 would be represented by x plus 4, but then the 0 is represented with the x, and so we'll throw that out front. We always like to put our monomial first. Okay, so now I want you to try 12 and 13. I'll give you a few minutes, and then we'll go over those to make sure you did them right. Negative 5 and a coefficient of negative 1. What degree is this polynomial? What degree is that? 7, because you got 7 zeros. So that makes the graph even or odd? Even or odd?
Odd.
Odd. So that tells you what about the end behavior? Opposite directions. Well, which way is it going to go? Down on the right. Oh, did I? Okay, so I can go ahead. Well, does it have any multiplicity? Yes. Yes. Where? At 2, we have a multiplicity of 2, which is a bounce. And at 0, we have a multiplicity of 3, which is a flatten out. Pay attention, guys. So if I go right 2, that's where it's going to bounce. I darken that in to let me know that's where my origin is. Okay, then if I go right 4, it just crosses through. At 0, it's going to flatten out. And at -5, it's just going to cross through. Okay, now I know that it goes up on the left, down on the right. Do you all know how we know that? Because we know it goes opposite directions because our degree was odd. And since our leading coefficient is negative, it has to go down on the right. So we'll come down, cross through, go back up, flatten out right here, go up, come down and bounce, and then go back down. Okay? Alright, sketch a graph with the following zeros: -2, +2, 4, 4, 4, and 6 with a coefficient of +1. What degree is this polynomial? 6. So what all does that tell you? It's even, so that lets us know our graph's ends behave how? The same way. And which way is that? Up, because it's a +1. So they're both going up. Now, do we have any multiplicity? Yes, there's a multiplicity of 3 at 4, which is a flatten out. So I'm going to go ahead and plot these. Let's see. I guess I'll go with it. I don't know. Is that it or is that it? Okay, so -1, 2. It's just crossed through right there. +1, 2. +4 is where it flattens out. And +6, it just crosses through. But I know both ends go up. So we come down, cross through, go up, cross through, come down, flatten out, go up, forever. Okay? Now, we didn't write the equation for the last one, so let's go back and do it. Y equals, what would go first? -x cubed, right? So that takes care of those 3 and the fact that it's negative. What else do we need? Right? Squared, that takes care of those 2 zeros. And then we need right. Okay, have you all written the equation for 13? Okay, go ahead and take a second and write that. The equation, who wants to give me the equation? Y equals what? Okay, Eric.
Y equals x plus 2 and x minus 2, x minus 4, and cube, and x.
Okay, is that what y'all got? Okay, right. Let's go to the next page. Yeah, I'm just doing one with y'all and the rest is yours to do. Okay. Now, the directions for this page say use a graphing calculator. However, I could take a 6th grader and teach them how to type that in the graphing calculator, and they would be able to copy it from their screen to their paper. You are proving that you know more knowledge about what these things do to the graph if you sketch it by hand. And then if you want to check it with your calculator to make sure it's right, that's the best way to go about this if you want to get yourself prepared. So, how many zeros are there? 2. What are they? Okay, so if there's 2 zeros, what's the degree? 2. So the graph is even or odd? Even. So that tells us what about the end behavior? The same. In which direction? Up, because it's positive leading coefficient. So they're both going to go up. Okay, now we don't really know what's going on in the middle. Now, I want you to do end behavior this way, and I want you to do it the other way we learned. As x approaches infinity, and as x approaches negative infinity. So you would write those on all of them. All of them would have x approaches infinity, x approaches negative infinity. It's the y's that change up from problem to problem. Okay, so let's graph this. If zeros are also known as x-intercepts, so I'm going to plot those places. I know they both go up. They just cross through, so it just looks something like this, a parabola. So, as I approach positive infinity, which means go to the right side. What are the y values doing? Going up, so positive infinity. As I approach negative infinity, going to the left, the y values go up. And doesn't it make sense that the y values approach the same thing since it was an even graph? And since the leading coefficient is positive, doesn't it make sense that they both be positive? Okay, so your classwork / homework is to finish the front of this page. So it's like 7 more problems.